Hello again. Today we're going to be talking about 9.2. We're going to be talking about reflections. In the last section we talked about translations where we moved graphs up, down, left, or right. In this section we are going to be reflecting images across a line of some kind. So how this is going to work, a reflection across line R, which we're going to call line R the line of reflection. It's going to be a transformation with these two properties, so one of two things could happen. If a point that we're reflecting is on line R, then the image of A is itself, so it doesn't move. The pre-image A is going to be the same as new image A prime. So if it's on the line that we're reflecting it across, it's not going to move. If a certain point is not on line R, which for a majority of what we're going to be working with, it's going to be case 2 here, they're not going to be on the line, then R is a perpendicular bisector between the points B and B prime. It's a perpendicular bisector, and again what that means, if we were to draw a line between B and B prime, not only is it going to make a 90-degree angle with my line of reflection, but the distance is going to be the same. That's going to be huge. It's the same distance from B to my reflection line as it is to B prime to my reflection line. So for our first example here, we're going to use the point P, which is at 3, 4. So 1, 2, 3, 1, 2, 3, 4. There's P. And we're going to be reflecting it across the line y equals 1 now. Y equals 1 is a horizontal line at y equals 1. So here's my reflection line, or line of reflection. The question is, what are the coordinates of its reflection image? So what we're looking for is P prime. So the first thing I have to do is I have to figure out how far away from my line is my point P. Now, horizontal or vertical is really easy to count distance. So if I go from P down to the line, I go down 1, 2, 3. My distance is 3. So in order to find P prime, I keep going 3 in the same the opposite direction. 1, 2, 3. Down here is P prime, and that is at the point 1, 2, 3, negative 2. That's how I'm going to find P prime. Now we're going to take that same point P from before at 3, 4, 1, 2, 3, 1, 2, 3, 4, and now we're going to reflect it across the line x equals negative 1. Now x equals negative 1 is a vertical line at x is negative 1, so there's my line of reflection. Now similarly to when we're reflecting it across a horizontal line, a vertical line is also very easy because we're going just counting how far P is from the line. So if I go from P, I go left 1, 2, 3, 4. So to get P prime, I keep going 4 more to the left. 1, 2, 3, 4. And there's P prime. And that happens to be at the point 1, 2, 3, 4, negative 5. 1, 2, 3, 4. So P prime sits at negative 5, 4. Now we're going to be taking 3 points and doing a reflection. We're going to form a triangle, so we need to plot these points first. A is at negative 3, 4. So here's A. B is at 0, 1. That's B. And C is at 4, 2. So there's C. Here's my triangle. Now what I'm going to do with that is I'm going to reflect it across the y-axis. So now here's my y-axis. Here's my reflection line, my line of reflection. So what I'm going to do with each one of these points is I'm going to find the distance between the point and the line, and then keep going in that same direction that distance. So for point A, I'm going to go 1, 2, 3 to the right. So that means to get A prime, I keep going 3 more to the right. So A prime is going to sit at the point 3, 4. I'm going to do the same thing with C. C is off on the right here. I'm going to go to the left. 1, 2, 3, 4 spots. So I'm going to keep going 4 more to the left. 1, 2, 3, 4. There's C prime. So C prime sits at 1, 2, 3, 4, negative 4 for X, positive 2 for Y. B is right here. B sits on the y-axis, which is my line of reflection. So if you remember from case 1, when we were talking about reflections, if it's on the line, it doesn't move. So if this is B, this is also B prime, which is at the point 0, 1. So now when I connect these new points, my reflection is going to look something like this in green. Our second example here, we've got the point A at negative 3, 0. We've got B at negative 1, 3. And we've got C at negative 3, 3. So here's our triangle right here. Now we're going to be reflecting it across the line X is equal to negative 1, which is this line right here. So what I want you to do is I want you to pause the video, find the reflection, and then once you have an answer, go ahead and hit play, and we'll see how you did. Okay, as you can see here, green shape is our reflection. You'll notice that A was 2 away from my reflection line. I had to go 2 to the right. So from my line, I go 2 more to the right to find A prime, sitting at the point 1, 0. C prime was sitting up here, or C was sitting up here. We had to go 2 to the right to get to the line, go 2 more to the right to get to C prime, sitting at the point 1, 3. B was on the line, so therefore when we do the reflection, B will not change. Okay, it'll stay in the same spot, keeping it at negative 1, 3. Now, the last couple of examples, it's been the same point that stayed. B has been the one that stayed. That's not always going to be the case. It just happened to be the case for these 2 examples. It could be any of the 3 in any given problem. For the last problem in this section, they kick it up a notch. Okay, we still have the same 3 points from the last one. So A is at negative 3, 0. B is at negative 1, 3. And C is at negative 3, negative 3, 3. So here are my 3 points. Now the difference is, instead of a horizontal or a vertical line like the last 2 examples have been, we are reflecting it across the line y equals x, which if you were to draw that, looks something like this. Okay, it's called the identity function. So we are now going to reflect our shape here across this non-horizontal and non-vertical line. How we're going to do that, first of all, you should know for y equals x, the slope is 1. The reason why that's important, if you remember from when we first started talking about reflections, in order to find a reflection image, the line connecting the 2 points, the pre-image and the image, need to be perpendicular bisectors to the reflection line. So my line has to be perpendicular to the reflection line. So if I wanted that, my perpendicular would be opposite reciprocal. Opposite reciprocal of 1 is negative 1. So all of my lines to get to my new image are going to have a slope of negative 1. So how that's going to look, if I start with A, if I draw a line from A that's got a slope of negative 1, it's going to look like this. You'll notice it hits the line at 1.5 distance, 1.5. So just like before, in order to get my new point, I'm going to continue 1.5 in that direction. So here is A prime, sitting down at 0, -3. For B, again drawing a line with a slope of -1 from B, 1, 2, down to that line. So now I keep going 2 in that other direction. There's where B prime is, sitting at the point 3, -1. Same thing with C. If I draw a line with a slope of -1 from C, 1, 2, 3. I have to go 3 that direction to get to the line, so I continue that direction 3 more. And there is C prime, sitting at the point 3, -3. And this is what my triangle will look like.